Today we're going to look at parallel lines. So let's get started. So here we're asked to write an equation for the line parallel to another line and containing the point 5, negative 3. So what we're given is the equation for a line y equal to negative 2/5 x plus 4. So here's the graph of that line. So we want a line parallel to this line, and this line should contain the point 5, negative 3. And here we have the point 5, negative 3. So basically, we want to find the equation for this line. So what does it mean for lines to be parallel to each other? Well, the concept of parallel lines goes back thousands of years. It's included in Euclid's Elements. It's in the definitions of Book 1. When Euclid defined these parallel lines, he said that parallel straight lines, well, these are straight lines being in the same plane and being produced indefinitely in both directions, that these lines do not meet one another in either direction. I will admit, Euclid's verbiage can be somewhat confusing, so let's summarize that. What that means is parallel lines never intersect in a plane. Again, we're looking at a two-dimensional surface, and on this surface, if two lines are parallel, they extend forever in both directions, but they never cross. They never touch each other. That means these lines are changing at the same rate. The rate of change is the same. That means that parallel lines have the same slope. So let's look at this question again. We want to write the equation of a line that is parallel to another line and contains the point 5, negative 3. So what do we know? Well, we know a point. We have the point 5, negative 3. And we know the slope. The slope of the line it's parallel to is negative 2/5. So we have an m of negative 2/5. That means the slope of the line that we're going to write an equation for is also negative 2/5. Now with this information, there's a couple of ways we can write an equation. I'll go ahead and use that point slope formula. So y minus y sub 1 equal to m times x minus x of 1. So this is y minus a negative 3 equal to negative 2/5 x minus 5. Now this is an equation, and it's an equation for the line parallel to y equal to negative 2/5 x plus 4 and containing the point 5, negative 3. It's written in point slope form. Let's go ahead and rewrite this in slope-intercept form because the original equation was in slope-intercept form. So y minus a negative 3, we're going to rewrite this as y plus 3 equal to negative 2/5 x minus 5. Use a distributive property to multiply out that negative 2/5. So that's y plus 3 equal to negative 2/5 x plus 2. And then we'll subtract 3 from both sides to get that y all by itself. We end up with y equal to negative 2/5 x minus 1. So here is an equation for the line that is parallel to y equal to negative 2/5 x plus 4. They both have a slope of negative 2/5 and then different y-intercepts. The original equation had a y-intercept of 4, and the line that goes to the point 5, negative 3 it had a y-intercept of -1. Let's try another one. Here we're asked to write an equation for the line parallel to the line 3x minus 9y equal to 2 and containing the point -6, 2. So to write an equation of a line, we need a point, and we do have a point. We have the point -6, 2. We also need to know the slope of the line. And right now we don't know it, but we do know that the line is parallel to another line. And parallel lines have the same slope. So let's find the slope of this line. And an easy way to find the slope is to write this in slope-intercept form. So we're going to write it as y equal to mx plus b. So let's isolate the y. So first I'll subtract 3x from both sides. This gives us -9y equal to -3x plus 2. And then we're going to divide both sides by -9. We now have 1y, or y, equal to, this is -3 divided by -9. We can simplify that down to 1/3 x minus 2/9. So with this equation, we now know the slope of this line is 1/3. And since the line we want to write is parallel to it, we also know that it has a slope of 1/3. So now we have the information we need to write our line. We have a point and a slope. And for this example, let's use the slope-intercept form to write this equation. Again, so we know the slope, and we do know one xy pair, this point we were given. So we can plug those values in. So we have a y of 2 equal to 1/3. Then our x value is -6 plus b. So now we have to find b. Well, this is going to give us 2 equal to -2 plus b. And then adding 2 to both sides, we have 4 equal to b. And then with this information, we can write our line. We have y equal to, our slope is 1/3, so 1/3 x plus b, and b was 4. Next, we're asked to determine whether the graphs of this pair of lines are parallel. So if we graph these two lines, would these lines be parallel? Again, since parallel lines have the same slope, we can compare the slopes of these two lines to determine whether or not the lines are parallel. Well, let's find their slopes. Well, the first equation, that's in slope-intercept form. So it has a slope of 2/3. The second one's in standard form, so we're going to have to rewrite this in slope-intercept form. So let's subtract 2x from both sides. We now have -3y equal to -2x plus 6. Then we'll divide both sides by -3. And this will give us y equal to 2/3 x minus 2. And again, we have a slope equal to 2/3. These two lines, they have the same slope. And if lines are parallel, they will have the same slope. But one more thing I'm going to check are these y-intercepts. Since I have both equations written in slope-intercept form, I can find those y-intercepts pretty quickly. And I want to make sure that these lines do not have the same slope and the same y-intercept. Because if they do, they're the same line. But for this case, we have a different y-intercept and the same slope. So yes, these two lines are parallel to each other. Let's try another one. Again, we're going to determine whether the graphs of this pair of lines are parallel. And we're going to start by finding the slopes of these two lines. So for this first equation, we have 5x minus y equal to 3. Subtract 5x from both sides. We now have negative y equal to negative 5x plus 3. So we have a coefficient of negative 1 in front of the y, so we're going to divide everything by negative 1. This is going to give us y equal to 5x minus 3. So our slope is equal to 5. And for the second equation, we're going to write it in slope-intercept form. So I'll start by adding 5x to both sides. We now have 2y equal to 5x plus 8. We have a coefficient of 2 in front of our y, so we're going to divide everything by 2. We have y equal to 5 halves x plus 4. So last time I checked, 5 halves is not equal to 5. So no, these lines are not parallel. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. For this first problem, we're asked to write an equation for the line parallel to a given line and containing a point. So the given line was y equal to 3/4 x minus 5. It's in slope-intercept form, so we can find that slope. It has a slope of 3/4. And then we have the point negative 8, 2. For this example, I use the slope-intercept form to write the equation. So we have a slope of 3/4, and then we have the point negative 8, 2. So our x value will be negative 8, and our y value will be 2. And then solving that equation, we get a y-intercept, or b, of 8. And then returning to that original slope-intercept form, we have y equal to, well, our slope is 3/4, so 3/4 x, plus our y-intercept, 8. For this second problem, we're asked to determine whether the graphs of a pair of lines are parallel. So if the graphs are parallel, they're going to have the same slope. So for the first equation, this was in slope-intercept form. So we can find that slope of 1/3. The second equation was in standard form. So rewriting this into slope-intercept form, we're able to find that slope, and it is negative 1/3. So 1/3 is not equal to negative 1/3. So no, these lines are not parallel. Drop any questions you have in the comments. Continue practicing working with parallel lines, and I'll see you in the next video.